Hey there, savvy sixth graders. In this video, we're going to continue our study of rates by talking about some additional word problems using unit rates. So in this first example here, we're going to talk about a pricing problem in which we'll use the unit rate to help us determine what is the better value for our money. So in example 1, we have a 12-pack of Orange Crush, which is priced at $3, and then we have a 6-pack, which is priced at $1.75, and we're going to try to find which is the better value. So to find the better value, I need to determine what is the unit rate of each of these different size packs of soda. So for my 12-pack, I know that the rate is $3 per every 12 sodas. So to find the unit rate, I need to divide the top and the bottom both by 12. So for my numerator, I have 3 divided by 12, which is going to give me a decimal. So that means I should probably do this work off to the side. Again, we're not doing 12 divided by 3, we're doing 3 divided by 12. So we'll set the problem up like this. 12 won't go into 3, so that means I need to make 3.0 and do some decimal division. 12 does go into 30 two whole times, so this will be a 0.2. And then if I subtract 24 from 30, I get a 6. I can bring down another 0. 12 goes into 60 5 whole times. And so what that means is $0.25 or 25 cents is what it costs for each soda. So that's for a 12-pack. Now we're going to do the same thing for a 6-pack. So for a 6-pack, again, it costs $1.75, so $1.75 per every 6 sodas. To make that a unit rate, I need to divide the top and the bottom by my denominator, which is 6. So now we have the long division problem 1.75 divided by 6. Again, line up your decimal points when you're doing long division with decimals. 6 will not go into 1, but it will go into 17 two times. So that's going to give me a 12. When I subtract 17 minus 12, I get 5. Bring down this 5. 6 goes into 55 9 whole times. And then I get a remainder of 1. Since all we're doing is we're trying to compare these two different unit rates, I can go ahead and I can stop here with my division. So I have 0.29 or 29 cents per soda is my second unit rate. And now if I compare these two unit rates, I can see that a 12-pack is actually the better deal because a 12-pack, it only costs 25 cents per soda as opposed to a 6-pack which costs 29 cents per soda. So the better value for this problem is the 12-pack. Okay, for our next problem, we're going to compare two different speeds by, again, finding the unit rate. So for example 2, it says that Hunter jogs 4 miles in 30 minutes, Ryan jogs 7 miles in 48 minutes, and we want to know who jogs the fastest. So for Hunter, again, we're given the rate of 4 miles per every 30 minutes. So to find that unit rate, I need to divide the top and the bottom by 30. So now I need to do 4 divided by 30. And just like for the last problem, 30 won't go into 4, so I need to make 4 a decimal by making it 4.0. 30 does go into 40 one whole time, so we'll start out with a 0.1. When I subtract 40 minus 30, I get 10, and now I can bring down another 0. 30 goes into 100 3 whole times. So now I have a 0.13. 3 times 30 is 90, and I get a remainder of 10. For these long division problems, we'll go ahead and we'll stop after 2 decimal places. So we'll round these to the nearest hundredth. And then if for some reason we need to keep going in order to compare our unit rates, we can keep going later on. But for right now, we're just going to round to 2 decimal places. And so we'll say that Hunter has a speed of 0.13 miles per every 1 minute. So now we'll go ahead and we'll take a look at Ryan's speed. For him, we're given a rate of 7 miles per every 48 minutes. So we need to divide the top and the bottom of that fraction by 48. So now I'll be doing the long division problem, 7 divided by 48. I again need to make 7 7.0. 48 will go into 71 whole times, so we'll start with a 0.1 again. 48 minus 70 is 22. And I'm going to bring down a 0. 220 divided by 48. I can put 48 into 224 whole times. And 48 times 4 is 192. And I get a remainder of 28. Again, I can stop when I get 2 decimal places. So now I know Ryan's speed is 0.14 miles per every 1 minute. So by comparing these 2 unit rates, we can see that Ryan ran slightly faster than Hunter. Ryan's running 0.14 miles per minute as opposed to Hunter's 0.13. So we would say that Ryan jogs the fastest. Okay, for our last example, it says John and Clark have a lawn mowing company. John can mow 3 average-sized lawns in 4 hours, and Clark can mow 5 average-sized lawns in 6 hours. Clark argues that since he is faster, he should get paid more. And do you agree with Clark? So the first thing we're going to do is we're going to figure out, is Clark actually correct? Is he actually faster? What I'd like you to do now is pause the video and show some work and try to figure out, is Clark indeed faster than John, or is he not? So go ahead and pause the video, and then when you have an answer, click play. Okay, so if you've found the unit rates correctly, you should have found that John can mow 0.75 lawns in 1 hour, and that Clark can mow 0.83 lawns in 1 hour. Again, here's the long division for that work. So we can see that Clark can mow slightly faster than John, 0.83 compared to 0.75. So to answer our problem, yes, Clark is faster. But then the second part of the problem asks you if you agree with Clark when he says that he should get paid more. So what I would like you to do is, tonight, I would like you to think about that. Should Clark get paid more than John? And then we'll discuss your answers to that question tomorrow. Be prepared to defend your thinking, okay, when you answer that statement. All right, if there are any questions you have over this video, be sure to jot those down. And until I see you again, have a nice day. You're all wonderful people. Bye-bye.